Polygon 2.0, a revolutionary upgrade to build the Internet of Value. Polygon, one of the leading Ethereum scaling solutions, has unveiled a bold new vision for the future of Web3 infrastructure, dubbed Polygon 2.0. This sweeping set of upgrades aims to transform Polygon into the first Internet of Value, a scalable and seamless network for exchanging, storing, and leveraging digital assets. At the core of Polygon 2.0 is a series of groundbreaking innovations leveraging zero knowledge (ZK) cryptography. Polygon plans to incorporate new ZK technologies like Polygon ZK EVM and Plonky 2 across its ecosystem, greatly enhancing scalability and interoperability. The company also intends to transition its popular Polygon proof of stake (POS) sidechain into a highly decentralized ZK Validium secured by the Ethereum mainnet. These changes will allow Polygon to achieve the two key properties of a true Internet of Value: infinite scalability and unified liquidity. Apps and services built on Polygon will be able to grow unbounded, while assets will flow freely across Polygon's network of ZK powered chains. The aggregate layer, enabling seamless cross chain value transfer. A major innovation powering this seamless exchange of value is Polygon's new aggregator layer. This layer combines ZK validity proofs from Polygon's myriad chains into a single recursive proof that is committed to Ethereum. This allows assets to be ported frictionlessly across chains while still benefiting from Ethereum security. For example, a user could instantly transfer tokens from a gaming dApp on one Polygon chain to the Polygon ZK EVM without relying on bridges. The user simply initiates a transaction on Polygon ZK EVM, which can verify via the aggregator layer proof that the gaming dApp chain has attested to the validity of the transfer. By recursively aggregating proofs in this manner, the aggregated layer will allow thousands of Polygon chains to interoperate as seamlessly as websites on the traditional internet. This unified liquidity is essential for supporting seamless user experiences and composability between Polygon dApps, transitioning Polygon POS into a highly decentralized ZK Validium. A major pillar of Polygon's 2.0 vision is the transition of its popular proof of stake sidechain into ZK Validium secured by Ethereum. This will dramatically enhance the security and decentralization of Polygon. So what happens right now is that the proof of stake it currently operates via checkpointing to Ethereum every 30 minutes. This means short-term consensus is handled by Polygon's POS validators with the checkpointing mechanism preventing longer-term reorganizations. With the move to ZK Validium, all Polygon proof of POS transactions will be proven directly to Ethereum in real time. Polygon's validators will become decentralized sequencers, aggregating transactions off chain and then generating ZK proofs to attest their validity on Ethereum. This elegant approach will make Polygon POS the most decentralized and secure layer 2 on Ethereum. Even if a majority of sequencers were compromised, they would be unable to violate consensus, as the integrity of all transaction history is guaranteed by second proofs enforced by Ethereum. By aligning Polygon POS consensus with Ethereum in this manner, assets on Polygon will benefit from Ethereum's rock-solid security. This enables vastly greater capital capacity relative to POS's current checkpointing paradigm, upgrading the Matic token into a hyper-productive governance token. To further enhance decentralization and align incentives, Polygon also plans to upgrade the Matic token into a new Pol token. Whereas Matic serves narrowly as a staking token for the POS chain, POI, Pol will be a multi-purpose hyper-productive token for participating in Polygon's entire network of chains. Holders will be able to stake Pol tokens to secure and provide services across Polygon's ecosystem. This includes acting as validators, sequencers, ZK proof generators, and even data availability providers on the Polygon app chains. Reward rates for these activities will be calibrated to optimize security, decentralization, and performance across Polygon's ever expanding landscape of chains. This flexible staking design makes Pol an exceptionally productive asset. Matic holders will be able to put their tokens to active use, securing and servicing numerous Polygon apps and services simultaneously. Earning opportunities will grow in direct proportion to ecosystem adoption. For these reasons, Pol will function primarily as a work token rather than a currency. Polygon believes work tokens aligned with network utility represent the next evolution from Ethereum style asset backed tokens. Work tokens create a return on work for actively participating in protocol defined tasks like providing security and data services. A new vision for scalable Web3 infrastructure. Polygon 2.0 represents a new vision for infinitely scalable Web3 infrastructure grounded in ZK proofs. This vision stands in stark contrast to previous approaches like sharding or off chain computation that promise unbounded capacity through sheer brute force. With the rigorous cryptographic guarantees, safety need not come at the cost of centralization. Polygon's Internet of Value demonstrates how Ethereum security can extend to millions of users across thousands of application specific chains, all operating seamlessly via advanced zero knowledge machinery. Much work remains to fully implement this cutting edge paradigm, but Polygon 2.0 provides a guiding vision of the future, one where Ethereum's magnetic security blankets an entire open economy of composable value chains. Key advantages of Polygon's Internet of Value architecture: infinitely scalable capacity for any application. Polygon's 2.0 systems of ZK app chain provides effectively unlimited capacity for every application. Popular dApps no longer have to compete for scarce throughput on general purpose chains like Ethereum, Polygon, POS, or Layer 2s. Apps can instead operate on their own dedicated chains with custom economics and unlimited room for growth, which are called sidechains. Seamless cross-chain value transfer. The aggregator layer enables frictionless movement of assets between Polygon's chains. Users can easily transfer value between dApps on different chains, allowing smooth cross-chain experiences. Enhanced security for the Polygon POS chain. By transitioning Polygon POS into a ZK Validium, security will be massively increased. Transactions are proven to Ethereum in real time rather than relying on periodic checkpointing. This makes POS the most decentralized and secure Ethereum layer 2. Hyperproductive POI token aligned for utility value capture. The new Pol token allows stakers to secure multiple Polygon chains simultaneously. This makes it a hyper-productive multi-purpose work token for return on work. Value accrues to Pol by inherently catalyzing ecosystem growth. Flexibility between Validium and ZK EVM model chains. dApps can choose between Polygon's low-cost Validium chains and premium ZK EVM chains with Ethereum equivalent security guarantees. The modular architecture provides flexibility for apps with different scale and security needs. Built around industry-leading ZK research and engineering, Polygon, ZK EVM, and Plonky 2 are widely considered best-in-class ZK proving systems. The product of years of intensive research and development, these technologies provide the scalability and composability underpinning Polygon 2.0. A clear path for migrating Polygon POS users. The POS to Validium migration provides a gentle upgrade path for users. The process is designed to be low touch, as validators simply need to update software and integrate ZK proofs into existing checkpointing logic. How Polygon is building the Internet of Value. Polygon has introduced several new technologies and products that collectively realize its vision for an Internet of Value. Polygon ZK EVM. It facilitates the creation of scalable ZK rollup chains secured by Ethereum. It allows transactions on these rollups to be validated by submitting second ZK proofs to Ethereum rather than excessive transaction data. The ZK EVM chain have cost several orders of magnitude lower than Ethereum while providing equivalent security guarantees. For example, it used to cost $50 per commit, and if there are infinite sidechains, or even if we take 1,000 sidechains, then what it meant was 1,000 into 50, $50,000. So it is if anyone who does not want to secure, for example gamers, they just want to show that yes, we are there and we are not meant to be banned, so this is the best system for them. And if you want multiple if extra security you want, and if multiple commits want to be made to the Ethereum chain, then even that can be done. if one needs it that ways. But uh, this this enables withdraw by this enables withdrawals in minutes rather than days. Uh, the days long waiting periods common on optimistic rollups. So its modular architecture makes Polygon zkVM readily adaptable for app-specific chains. These validiums reduce costs further by handling data availability of Ethereum while still benefiting from Ethereum security. The Plonky 2 proving system. The Plonky 2 is Polygon's next generation ZK proof generation engine. It leverages several key innovations. A new proving algorithm that significantly reduces proof times, allowing validator nodes to easily scale up proof generation to match demand. Efficient verification of proofs on Ethereum, minimizing transaction call data costs. An elegant proof format that reduces errors and allows transparent auditing. Plonky 2 enables low cost and highly scalable ZK proofs for securing Polygon's ecosystem of chains. Polygon Nightfall. To support enterprise use cases, Polygon is integrating privacy preserving ZK technology from startup Nightfall. This enables private transfer of assets like securities across Polygon chains, opening up applications in tokenized finance. Polygon Avail. For Validium chains that don't post data to Ethereum, Polygon Avail provides fast and decentralized data availability. It combines secret sharing schemes with pseudo random data distribution to provide robust data availability without expensive Ethereum storage. Polygon Maiden VM. To support non-EVM compatible chains, Polygon is developing Maiden VM, a ZK roll-up chain for arbitrary computation. Developers can leverage languages like Rust, C++, and Go to build on Maiden VM using more efficient and expressive tooling. So this is basically support for all different various domains and languages. So, the aggregator layer. So the aggregator layer is the crown jewel of Polygon 2.0. It serves as an interoperability hub for transferring assets between Polygon chains. It combines validity proofs from across Polygon's ecosystem into a single recursive proof submitted to Ethereum. This breakthrough allows liquidity to flow seamlessly while retaining Ethereum security. It is a key innovation for realizing Polygon's vision of an open and interoperable multi-chain platform. Transitioning Polygon POS to a ZK Validium. Upgrading Polygon's high traffic POS chain to a ZK Validium is a major undertaking. Here are the key steps involved. Firstly, initial community signaling. First, the developers submit a Polygon improvement proposal outlining the proposed Validium architecture. It kicks off an initial discussion in Polygon forums to gauge community sentiment. Secondly, in-depth public technical review. Next begins a detailed public review process. Polygon's engineers publish specifications, documentation covering all technical facets of the upgrade. External auditors and community members will analyze design and provide feedback. Thirdly, user and ecosystem preparation. With rough consensus on the upgrade plan, Polygon begins user and ecosystem readiness activities. This includes communicating timelines, developing token user guides, coordinating with wallets and explorers, and ensuring dApps are compatible. Fourthly, deployment of smart contracts. New validator smart contracts will be deployed in Ethereum with extended time windows for community audit. These contracts will handle validity proofs and have additional functionality like fraud proofs. Fifthly, client upgrade and testing. Validator nodes will upgrade their software to Polygon POS version 2, which integrates ZK proof generation and submission to Ethereum. Multi-client testnets will be coordinated to detect issues before mainnet upgrade. Sixthly, token holder voting. Once the community feels prepared, token holders will formally vote on activating the Validium upgrade on a specific epoch. This vote coordinates a live mainnet upgrade. Seventh, upgrade epoch. At the target epoch, the validators will point their nodes to the new version 2 chain, which enforces ZK proofs and begins operating as a ZK Validium. User funds are seamlessly transferred over in their accounts. The live upgrade event will proceed cautiously with extensive monitoring and security reviews. But based on results from testnets, the process should be smooth and essentially transparent to users. By following this careful rollout plan, Polygon aims to upgrade POS without disruption. If successful, it will serve as a blueprint for transitioning high-value chains into decentralized and secure ZK Validiums under Ethereum's protections. Evolving Polygon's governance Web3's infrastructure phase. To further decentralize Polygon and provide sustainable funding for development, Polygon 2.0 also proposes a new governance framework with three pillars. Firstly, protocol governance. This covers network upgrades. Contributors create PIPs which undergo community review similar to Ethereum's EIPs. Approved PIPs fund ongoing technology improvements. Secondly, system smart contract governance. For system critical smart contracts like staking and bridging, a transparent multi-sig process will be used to upgrade contracts. Standard will be pioneered to make multi-sigs more trustless and verifiable. Thirdly, community treasury governance. A portion of transaction fees will fund an autonomous community treasury. Contributors can obtain grants for open source tools benefiting Polygon's ecosystem. The treasury will be governed in a decentralized manner by the protocol stakeholders. This expanded governance framework will foster greater decentralization and self-sustainability as Polygon progresses into its next chapter. While less important in the early bootstrapping phase, rigorous governance is critical infrastructure for managing community-owned networks at scale. Upgrading Matic into the multi-purpose Pol token, Matic has powered Polygon to become the leading Ethereum scaling solution with billions in stake value and millions of monthly users. But as Polygon moves to a multi-chain future, the narrow Matic token requires an upgrade. Introducing Pol, a hyper-productive token aligned to promote security, decentralization, and performance across Polygon's growing landscape of chains. Built for a multi-chain world. While Matic only provides the ability to stake on Polygon POS, Pol will offer flexible staking opportunities across all Polygon's chains. These include validating and sequencing transactions on specific chains, operating ZK-proof generating nodes, providing data availability services for Polygon dApps, participating in the aggregator layer to enable cross-chain transfers, service chains like block explorers and shared Oracle services. This gives Pol holders numerous options to actively secure and service Polygon's ecosystem. Matic is a single-purpose token, while Pol is inherently designed for a multi-chain Web3. Its broad utility makes Pol an exceptionally productive asset. Stakers can multiply their earning power and impact by staking across many chains, maximizing return on work. Calibrating incentives via fee routing. To optimize decentralization, security, and usability, Polygon must appropriately direct fees to its many service providers and staking pools. This is challenging in a diverse landscape encompassing public chains, enterprise validiums, scaling solutions, oracles, wallets, and beyond. Pol provides a mechanism to calibrate incentives. Transaction fees can dynamically fund Pol stickers across this diverse array of services based on need. Essential but understood pools can have fees routed to provide adequate yield. If availability is abundant, excess fees can be reallocated elsewhere. This allows Polygon to holistically optimize security economics across its ecosystem via fee routing. Matic only allowed simple staking of one chain. Pol enables fluid distribution of incentives. Transitioning the Polygon community. Transitioning such a heavily used asset like Matic is not simple. Some lessons learned from the Pol conversion process. Communicate early and clearly. Polygon published initial materials and specifications over a month before the conversion proposal to ease comprehension and feedback. Not surprising the stakeholders. Pol conversion has been extensively telegraphed to public community calls over the past year. While many details have evolved, stakeholders are aware of changes are coming. Incentivizing early participation. Encouraging testing and feedback. Polygon has offered high staking deals for converting Matic to testnet Pol. This surfaced issues early, making migration easy. For ordinary users, swapping Matic for Pol will happen seamlessly via UI, but Polygon has tried to ease even advanced migrations, allowing delegators to retain delegation status through transition. Leverage multi-client ecosystem. By utilizing Polygon's diverse ecosystem, wallets and explorers automatically handle the token migration. Users can migrate seamlessly without centralized coordination. While challenging for an actively used asset, Matic's transition aims to balance sufficient preparation with timely execution. By converting Matic into a more aligned Polygon has realized its vision for an incentivized Internet of Value. Evaluating Polygon's path to a multi-chain future. Polygon has rapidly gained adoption for providing a high-performance dApp platform secured by Ethereum. But as the Poly team reflected on the desired end state, they realized that neither a single chain nor a loose federation of chains would suffice long term. True usability requires a free flow of value across Polygon's ecosystem. Siloed assets impede seamless cross-chain experiences, while loose bridging breeds fragmentation. Users should be able to freely engage with every component of Polygon's network without exhaustive bridging procedures. This demands built-in interoperability spanning scaling solutions, sidechains, enterprise validiums, and more. After substantial research and development, Polygon concluded like cryptographic proofs, were the only feasible path to provide this cohesive user experience. By recursively aggregating and submitting ZK proofs to Ethereum, Polygon's chains have frictionlessly interlinked while inheriting Ethereum's security guarantees. This model ultimately leads to Polygon's 2.0 vision. Polygon's design is a product of continuous refinement. Its development provides lessons in blockchain R&D. Iterate in the open. Polygon has benefited from transparently testing various approaches with users rather than developing privately for years. Real world feedback drove better designs. Favoring specialization. Chains with custom features and economic outperform general purpose designs. App specific validiums are the future, so start with application specific rather than universal designs. Thinking long term. Short term optimizations like checkpointing sidechains inevitably hit limits. Only zero knowledge mathematics unlocks true scalability bound to Ethereum. Let the metagame evolve. Polygon's early L1-esque design drew assets and mindshare while ZK technology matured. This bootstrapping phase organically flowed into the ZK secured interoperability paradigm, built bridges between communities. By bridging the cultural gap between application developers and zero knowledge researchers, Polygon could integrate and advance ZK proofs. Embrace proof skepticism. Polygon's open and enthusiastic community rigorously scrutinizes the security model. This built faith in ZK machinery and the path to Ethereum secured.